So this project is partially funded by us. Compared with underactivity with obstruction, it bothers up to 1/3 of elder male patients. Also, the current only gold standard for diagnosis is pressure flow study. Of course, it's invasive, and they cannot be differentiated from each other non-invasively due to the similarity of the low maximum flow rate. So obstruction patients may have normal detrusor contraction with obstructed outflow, while underactive patients may have weaker detrusor contraction, and they may assist voiding with additional abdominal straining. Can this feature be reflected on the urine flow rate data? And if we can use it to differentiate these two symptoms based on free flow data. So through our last 5 years research, we have been proposed several non-invasive indicators, but each of them have quite limited diagnostic accuracy. It's best to be like a little bit above 70% of accuracy. So the aim of this research is to use a neural network model to non-invasively differentiate underactivity from obstruction. We have 2 separate studies. The first one, we want to try if we can use a pure shape to differentiate these 2 dysfunctions. And our further analysis is by employing parameters which is derived from free flow data in both time and frequency domain. So the artificial neural network has the features of nonlinearity and is capable of learning and has feature of adaptability. We use a feed-forward neural network in the MATLAB. We only use one hidden layer to avoid overfitting due to we currently only got small scale of data. So to validate our results, we split the data randomly with 70% for training, 15% for validation, and 15% for testing. So here's the basic flow chart for our neural network model. So we got the input data going through the hidden layer, output layer with the initialized weights. And then we get the output values. We compare this value with the target, which is the urologist diagnosis. And we got the loss value through the loss function. Then we can further update the weights by calculating the gradient. So this whole procedure will be continuous running until a certain number reach our certain small value of loss achieved. So in our initial analysis, we want to try the flow shape by normalizing all free flow data with 1,000 resample points and maximum amplitude 1. By doing this, we've taken out the voiding time and the maximum flow rate. So the only thing we consider in this analysis is flow shape. We got more than 100 or 300 data in 2 groups, generating the result. So for this study's results, we yield only 70% of accuracy with quite poor sensitivity and 82% specificity. So we realized that flow shape couldn't be sufficient to serve as an indicator. Therefore, we conduct our further analysis by employing the non-invasive urine flow rate parameters. We separate this into 3 groups. The first group is most easy one to get. We can just get it from the Uroflowmetry, including the maximum flow rate, average flow rate, and ratio of Qmax time to the voiding time. Second group may need a little bit calculation and also a little bit filtering techniques. We use the mean flow rate in the rising and falling part, ratio of flow time to the voiding time, and ratio of average flow rate to the maximum flow rate. So third group may need a little bit complex mathematical calculation. The first one, we use median power frequency analysis. We use a bandpass filter and got the filter curve. We use a fast Fourier transform to generate the frequency spectrum and the power spectrum. Then we can calculate the median frequency point. We also try to split the whole flow curve into 2 parts by the maximum flow rate points. and generate and calculate the median frequency in each part. We also did the analysis of peak number counting. We apply the filter 1 Hz on the raw curve and count the peak numbers in 1 Hz filter date. Also 0.1 Hz filter curve and count the peak numbers in it. Then do a simple ratio between it. We have also tried the modeling technique. We use a time constant value to represent the flow curve shape. But we only found statistical difference, significant statistical difference happens in the following part. Also, we did some more amplitude changes. We applied the bandpass filter on the raw flow curve, but we only count the amplitude difference in each of green part and sum it together. So for the results, we use the same data set. We got 79% accuracy in the training, and we yield almost exactly the same in the testing for in the overall accuracy. In specific, we got 75% sensitivity and 83% specificity. So for our conclusion, we think the artificial neural network holds the promise for the non-invasive discrimination. Also, it has much improved accuracy than any other single indicator. And also it has high reliability and the type 1 error tolerance. We also did cross comparison between other models, including linear model, multivariance analysis, and decision tree model, which is classification and regression tree analysis. So we can see the neural network model yields 79% accuracy, a little bit lower than the MANOVA model. But you can see this is most robustness. So we believe this holds a promise, and it has the best robustness and reliability. For our further study, we want to try the convolutional or recurrent neural network, see if we can further improve the results, and we want to include normal data to just diagnose underactivity and obstruction. Thank you for your patience.
Yeah. Any questions?
Yeah. I don't know how others in the room feel about it, but I'm a physician. I have no clue what you're talking about. Nonetheless, your conclusions look very interesting. The one thing I would suggest as next step, rather than what you're proposing down there, is if your model works quite well on Uroflow done in your institution, to convince me that whatever you're doing, what I don't understand, is real, taking Uroflow data from someone outside your institution, especially just a normal doctor's office. And if in that type of data you can confirm your conclusion, you would get very close convincing me that this is very useful. Otherwise, I think that could be interesting for in-house use in Bristol, but I'm not so sure whether it has a real applicability to what people the world over are doing.
Thanks for your suggestion.
Okay, please.
Sakakibara from Japan. Thanks very much for your interesting report. Could I just ask about the definition of the two groups, underactivity and BOO? And is it depending on the pressure flow analysis?
I think we use BCI and BOI, but I can't remember exactly for the definition. Yeah, Andrew provides the date. So it was diagnosed by a physician, and post-surgery patients was excluded. So the definition is exactly the same as in the paper on European urology of the signs and symptoms on differentiating obstruction and underactivity.
Next question, please.
Yeah. Why did you choose to normalize for Qmax instead of normalizing for volume. I would think that by normalizing for Qmax, you tend to lose the variability in the pattern of the flows.
Well, actually, we have been trying to not normalize Qmax. We also try to only normalize the volume time. The results was, this results gets much better, accuracy. So we have kept that.
But you said
we didn't try to normalize on volume because we didn't find any volume weighted difference between two groups.
Well, some of the work that we've done with flows show that if you volume correct your flows, you can see significant differences in flow characteristics. So I would probably recommend that you try normalizing for volume.
Yeah, okay. I will try it.
Okay, I have a final question then. And that is that yesterday I listened to Dr. Doberfool from Stanford, and she reported that patients with detrusor underactivity, they were improved by TURP, which is the standard treatment for outlet obstruction. And what do we gain by identifying the detrusor underactivity patients in a separate group than patients with outlet obstruction, if the treatment will be the same?
Well, I think the treatment could be the same, but currently the standard in UK for the treatments in UK for the obstruction patient is surgery, and underactivated might be the prescription. So the treatment might be different. So I mean, by using this, I think we have the possibility to let a partial of patients do not need to go through the pressure flow study, and they can just either taking the surgery or just get a prescription.
Okay. Thank you.
Thank you.
Thank you very much.